I'm Kendall Robert, and today we're going to learn to graph systems of linear inequalities using just one color. Now in this case, we have three linear inequalities. Y is greater than or equal to negative 1/3 x, x is less than 4, and finally, y is less than or equal to 1/2 x plus 2. Let's start with the first one. We always start by graphing the boundary line with a linear inequality. So we can picture this as y equals mx plus b. So the slope is negative 1/3 and the y-intercept is 0. So if we start at the y-intercept at 0, 0, and we look at the slope of negative 1/3, that means we're going to go down 1/3. Now because this is greater than or equal to, we're going to use a solid line when we graph it. The line we just graphed is called the boundary line. It divides the graph into two half planes. What we need to figure out now is which of the half planes represents a y that is greater than or equal to negative 1/3 x. The best way to do this is simply to pick a point and test it. Let's pick the point 0, 2, located right here. At 0, 2, the x-coordinate is 0, so 0 times negative 1/3 is 0. And our y-coordinate is 2. So is 2 greater than or equal to 0? Yes. That's going to mean we're going to shade this half plane. Now instead of shading, here's the little trick. We're going to use what I call hairs. All we do is we draw little tiny hairs extending off our boundary line, pointing in the direction of the half plane we need to shade. Now we've completed the first linear inequality. Graphing the second one is x is less than 4. This one's a lot easier. X is equal to 4 would simply be the boundary line located at all the x equal to 4 coordinates. So 1, 2, 3, 4 over on the x-axis is right here. Now, because we have less than and not less than or equal to, we have to use a dashed line to represent the boundary. Now again, we can plug in a point here, but if we just think about what x's are less than 4, that's going to be all of these ones over here. So again, we're going to draw little hairs extending into the half plane, which we intend to have shaded. The final inequality, y is less than or equal to 1/2 x plus 2, can be considered in slope-intercept form again. To graph the boundary line, we consider y equals 1/2 x plus 2. The y-intercept is 2, and the slope is 1/2. That means we're going to go up 1/2. Up 1/2. Because of the equal than part of the inequality, we can use a solid line again. Once again, we need to figure out which half plane we're referring to. So let's test the point 0, 0. At 0, 0, the x-coordinate is 0, and the y-coordinate is 0. 0 times 1/2 is 0, plus 2 equals 2. And 2 is indeed greater than or equal to 0. which means we're going to shade this half plane. I'm going to draw the little hairs one last time. And there we have it. All of our boundary lines are now complete. Now we need to figure out where all of these regions intersect. By carefully examining the little hairs we drew, we see that inside this triangle, all of these inequalities are true. So we're going to shade this triangle. This method is advantageous if you're used to using 3 different colors and all sorts of overlap. Here we can do it with a simple, non-colored pencil and avoid a mess. This region represents all the coordinates that will satisfy all 3 of these linear inequalities.